Hello, everyone. Welcome. We'll just give a few more minutes maybe for everyone to join in. So I'm seeing everyone. Jordan, do you have the PowerPoint back up?
I am putting it up
Okay,
right as we speak. It is spinning
fantastic.
like crazy.
We've had nothing but technical issues this morning. We were all ready to go, and then our internet in the building cut out. So I'm using my personal hotspot, so hopefully that'll keep me going here throughout this session. I am Myrna Grawn. I'm the Executive Director for the Canadian Association of Agri-Retailers, and we are thrilled to have you all join us for this Care Connect session. I haven't been able to be at the last few, so it's great to be able to join you today. And I just want to give a brief overview of who CARE is. We are the retail member association, so we represent the ag retailers across Canada, as well as have a number of other categories of membership, including suppliers. Here's our CARE staff team. So Jordan, you've met probably. He's the one that's going to be running the show and facilitating our session later. Oh, and I lost it now. There we go. And so where is that going there, Jordan?
Who knows?
We have we have Diana. Quit playing with your screen. We have Diana joining us. She works as our office administrative coordinator. Lisa is here today, and she's our both member relations and training coordinator. And then, of course, I think many of you know our board of directors. We have representation from BC to Ontario, but we will be adding someone within the year from the Atlantic provinces. If we can move along. Excellent. So if you'd like to connect with the CARE office, this is the different ways to do that. If you aren't following us on some of the social media platforms, Jordan's our key person on staff that is putting out that content. And I encourage you to join us and learn what's happening through some of those platforms. And you can also, if you don't already get our newsletter, you can sign up for that as well. So with that, Jordan, I'll turn it over to you, or I'm not sure what the next slide is. Oh, there you
Sorry,
go.
no.
Oh,
I was gonna say it's
oh,
our
our
next.
upcoming, oh, sorry,
Yes.
our next session, we have Dr. Barbara Cade Minham, and she's a research specialist that's going to be talking about phosphorus cycling in soil and water and insights from research in southern Saskatchewan. So she's going to be joining us next Thursday. And also, so that all of you know, you can get a continuing education point for these sessions. So make sure you connect with us so that you can get that accomplished. There's a little evaluation survey quiz that you need to fill out just so that the Prairie CCA knows that you completed the course or the session.
Now I'm
And
actually
now over to you,
yes,
Jordan.
but I'm gonna
Okay.
stop sharing for 1 second as I just realized that as we had that outage, my information has dropped off on Dr.
For Judith,
Judith.
so Dr.
Yes,
Judith
I got it right here.
Naran. Okay, you got
Yeah,
it.
yes,
Okay.
sorry.
Excellent.
Uh,
Welcome to Judith, and over to you, Jordan.
Appreciate it. So Dr. Judith Niareza holds a Bachelor of Science in Agricultural Science, a Master of Science in Soil and Crop Sciences, and a PhD in Soil and Environment. Her research focuses on evaluating how regenerative soil management practices, including nurse crops, summer and winter cover crops, and both conventional and alternative soil amendments affect soil health, crop performance, and carbon and nitrogen cycling in potato-based production systems. Her work has also identified innovative strategies to improve phosphorus use efficiency in potato cropping systems, supporting both productivity and environmental sustainability. Dr. Nia Reza currently leads a pan-Canadian living laboratory project that brings scientists and growers together to accelerate the adoption of environmentally friendly management practices across agricultural systems. In recognition of her contributions to the sector, she was named one of the 2023 influential women in Canadian agriculture and was inducted as a fellow of the Canadian Society of Soil Science in 2024. Dr. Judith, I'm going to throw it back over to you. And if you put up your presentation, we will listen in. And for all those wanting at the end, we do have a Q&A section. We encourage in a big way that you do get involved because this is your chance to ask an expert in this area all the questions you may have. And we also love seeing your faces. And this is something we say every single time. You are more than welcome to turn your camera on and be involved that way. Or if you choose, stay there and just listen. And now on to the presentation.
Judith, I think your microphone might be off.
I was muted. Can you hear me well now?
Yes, we got you.
Okay, perfect. So thank you so much for inviting me. So I'm based in Charlottetown in Prince Edward Island, and I'm going to talk about the impact of potato rotations and nitrogen management on potato yield and the greenhouse gas emissions. So this is the outline of the presentation. But first of all, I'm gonna thank my collaborators, my colleague from Charlottetown, Dr. Tendra Fraser, Danielle Marnahan, Jessica Matheson, Jennifer Klaus, Dr. Morteza Mespa, and my colleague from Fredericton, Dr. Aikechuk Agomo. So this is the outline for my presentation. Because some of the people in the audience may not know the PI soil and cropping systems and our agri-environmental issues, I will just give an introduction. And then I will touch base on case study to address some of the agri-environmental issues we are facing. I will talk about the practical implications of the preliminary findings and ongoing research work which is linked to the presented preliminary findings. So PI soils, as you may know, they are pathogenic soil high in iron content, acidic soils. So we have sandy loams most of the time. They are well drained and fertile soils, and they are very low in organic matter, basically 3 to 4 maximum, very prone to erosion, and the soil organic matter is decreasing quickly. So on your right side, you can see how our soils look like after a heavy rainfall, especially when there is no cover on the ground. So the PI also relies entirely to the groundwater for drinking water. So this map is showing the nitrate levels in wells, and where you see a red color is where we have found 15 to 20 wells containing nitrate levels above the drinking water guideline.
Sorry to disrupt you, Judy. Sorry, your screen share just got unshared. If you can just do another screen share again, my apologies.
Okay, got unshared. Okay, let's start again. One second, I don't know what happened. Just lost it.
Perfect, thank you. Sorry about that. Oh, it just went away again. There we go. Just
My apologize.
no, that's okay. Perfect. Yeah, thank you very much.
So I was here, so talking about the land use on right side. So yeah, you can see in red we have potato, yellow grain, purple soybean, and green we have forage, pasture, or grass. So you can see there is a correspondence between area cropped to potatoes and high nitrate above the drinking water guidelines. So because of this issue of nitrate leaching, there was a commission in 2008 that established a mandatory 3-year rotation system in PI. Basically, the traditional rotation will be a small grain, mostly barley, underseeded with red clover, and then red clover in the second year, in potato in the third year. So this 3-year rotation was meant to reduce the nitrate eroding to groundwater. And as you know, every rotation we have over time is issues. So we did see some negative impact associated with this rotation. So having red clover prior to potatoes, because most of the time in our soils we do a fall plowing, so we're gonna incorporate red clover in fall. We observed a higher nitrate leaching following cover crop incorporation. We also observed sometime reduced potato yield, because having high nitrogen in the soil sometime in our short growing season will extend the vegetative phase of potato and reduce potato tuberization, resulting in depressed yield. We also did see increased root lesion nematode and wireworm. On the other side, we did see improved soil properties with this rotation compared to other rotation, such as aggregate stability in the 0 to 15 centimeter depth, and enhanced carbon and nitrogen stock in the top depth. So there are alternative rotations to red clover. So now there is more and more people exploring other rotations, such as including sorghum Sudan grass prior to cropping potatoes, or using pearl millet or brown mustard or buckwheat. Basically, brown mustard and buckwheat were found to reduce the infestation by wireworm, and sorghum Sudan grass and pearl millet were also found to not be host of root lesion nematodes when they are cropped before potatoes. The issues we are facing include declining soil organic matter, stagnant potato yield, high residual soil nitrate after harvest, and extreme weather event. But this is a worldwide issue, is not only associated with PI. So for example, as you know, in 2025, we had a very dry year across the country. And these were titles in the journals just showing the impact that drought could have on potato yield. We had 44.8 millimeters of rain in July 2025, and that's basically a 50% reduction in rainfall compared to a 30-year average. So as you heard, greenhouse gas emissions are the main driver of climate change. And there are ways we could mitigate greenhouse gas emission. We could either increase the carbon sequestration that could offset carbon dioxide emissions, or we can manage nitrogen fertilizer to reduce nitrous oxide emissions. And as you know, the nitrous oxide emission is around 310 more potent than carbon dioxide. So the objective of the study I am going to present were to evaluate the impact of potato rotations and nitrogen management on potato yield and greenhouse gas emissions in 2024, focusing more on carbon dioxide and nitrous oxide emissions. So we are comparing here 3 rotation systems. So we have one rotation that includes grain corn in the first year, sorghum Sudan grass in second year, and potato in third year. So this is a high carbon input rotation. And then we are comparing it with a barley underseeded with red clover in the second year and potato in third year. And this is a high nitrogen input. So they are color coded all through the presentation. So the first one with high carbon input will be in blue. The one with nitrogen input will be in red. And then we do have a third rotation that is a soybean, brown mustard, and potato. And this is supposed to be the one associated with low carbon and nitrogen input. So we do have 2 cash crops over 3 years. I want just to tell you how we manage the residues in the second year. So the second year, basically, we do have a service crop, so no harvested crops. And they are all flayed mowed during the growing season, and the residues are returned to the soil. So they are not exported. But for the barley red clover, at the barley harvest, the straw is exported. That's what our growers do here. So the rotation we are comparing, they're going to be abbreviated as corn, sorghum, Sudan grass, potato, so CSSP, and barley forage legume P is gonna be BFLP, and then soybean, brown mustard, potato. So this is the layout in the field. So we have our 3 rotation systems in one field, and in adjacent field we have the same rotations. Why is that? It's because originally we were assessing the impact of the irrigation. Irrigation was happening only during potato phase. And the irrigation happened only in 2017 and 2021. We were testing the drip irrigation, and we stopped testing irrigation systems, but this rotation continued until now, from 2015 until today. So in 2024, we decided to test the effect of rotations, but also effect of nitrogen management. So site A, which did not used to be irrigated, we compared urea at 106 kilogram nitrogen per hectare versus Super U at 120 kilogram nitrogen per hectare. So we were reducing nitrogen rate by 25%. Then on the site B, we compared the urea at 160 kilogram versus urea 120 kilogram nitrogen per hectare. So, you know, Super U tend to be more expensive. So we're just, we wanted to provide growers with answers. If someone wants to invest more money or just reducing nitrogen rate using the cheapest options, what would be the impact on yield, but also on greenhouse gas emissions? So this is just to show you in the field how the layout looked like. So we basically took the main plot and we split it in 2, and then one side received 160, the other side received reduced rate. So the left side of the field, we were comparing urea versus super U, and then the other side, we're comparing urea versus 120 versus 160. So what did we analyze? So we basically sampled the cover crop dry matter biomass in the second year. So I will present the sum of the result in 2016, 2019, and 2023. And then we calculated the carbon and nitrogen accumulation just to give an idea how much nitrogen and carbon are returned to the soil through the cover cropping. And then we also assessed mineral nitrogen during the growing season, that is in 2024. We also assessed the potato total and marketable yield and greenhouse gas emission during potato phase, on hill and furrow. Because there is a microtopography difference when you are cropping potatoes, to have a good idea on what's going on in terms of greenhouse gas emissions, we sample on the hill. As you know, on the hill, that's where we burned nitrogen fertilizer. And on the hill, so we have a source of nitrogen fertilizer, but the soil is loose. But in furrow is more compacted, and also water tends to be accumulated here, and moisture is an important factor driving nitrous oxide emissions. So here I'm presenting you the results of cumulative dry matter accumulation, that figure A and B. And then figure C and D, we have cumulative carbon accumulations. And then figure E and F, cumulative nitrogen accumulations. So the red is the barley forage legume potato. The blue is corn, sorghum, Sudan grass potato. And the green is soybean, brown mustard potatoes. So as you can see, for the dry matter accumulation in metric ton per hectare, we can see we have highest value with corn, sorghum, Sudan grass, and lowest value with brown mustard. In general, the carbon accumulation will follow the trend of dry matter biomass. So we can see in figures C and D that we have highest carbon return to the soil with corn, sorghum, Sudan grass, and soybean, brown mustard having the lowest values. So for the nitrogen accumulation, as you would expect, the rotation that includes a legume and the sorghum Sudan grass, they have highest nitrogen return to the soil, and brown mustard has lowest values. So as you can see, the brown mustard is returning lowest carbon and lowest nitrogen input, and the sorghum Sudan grass is returning more carbon and more nitrogen, whereas the legume is more nitrogen input. We did also analyze the mineral nitrogen, that is ammonium plus nitrate, during the growing season, doing monthly soil sampling. So you can see that during June and July, the rotation that was including a legume was showing higher mineral nitrogen available in the soil over the growing season. And this is something expected, and we have seen this in previous studies, except that having more mineral nitrogen in the soil than needed by the crop can actually depress yield. In fact, when we assessed the effect on marketable yield in the next slide, we did not see any significant change in yield. We can see that our rotation systems have comparable yield, but also applying nitrogen rate at 160 kilogram or reduced rate did not impact our yield. Let's now see the effect on greenhouse gas emissions. So we do have in figures A, B, and C, this is the total seasonal carbon dioxide. And we are comparing rotation systems between them. Then we are comparing urea versus reduced urea. And then we are comparing the sampling location, hill and furrow. So this is urea versus reduced super U. And as you can see, for the comparison between rotation systems, you can see lower carbon dioxide with brown mustard. This is the total seasonal accumulation. On the figure B, when we compare urea versus reduced super U, we see comparable data. And also when we compare hill versus furrow, we have a comparison of the results. When we assessed nitrous oxide emissions, you can see that the rotation that included a legume has higher nitrous oxide emissions, and the rotation including brown mustard have lowest values. Whereas when we compared urea versus reduced super U, we observed that we could reduce nitrous oxide emission by almost 6 times. And on the right side, for the total nitrous oxide emissions comparing hill and furrow, we can see that we have higher value on hill than in furrow for nitrous oxide emissions. So that was for site A. When we go to site B, where we compared urea versus reduced urea, again, here we have total carbon dioxide for figure A, B, and C, and then nitrous oxide emission for figure D, E, and F. So we observed a trend with, here we have the sorghum Sudan grass and the rotation including a forage. They were comparable. And we have lower value with the rotation including brown mustard. And then we had comparable value for urea versus reduced urea for carbon dioxide. But we observed for hill and furrow that for carbon dioxide and nitrous oxide emission, that figure C and F, we did see a higher value on hill than on furrow. And when we analyze total nitrous oxide emissions, comparing urea at 160 kilogram versus 120 kilogram per hectare, we can see that we had 46 reduction in nitrous oxide emissions. So basically for potato feed, it would be important to assess nitrous oxide emissions or carbon dioxide on hill and furrow. We did also analyze the correlation between mineral nitrogen, specifically nitrate, in the soil over the growing season versus nitrous oxide emissions. and we did see a positive correlation. So the more nitrate available in the soil, more likely you will have higher nitrous oxide emissions. So take-home message, all tree rotation resulted in comparable potato yield in 2025. Reducing nitrogen fertilizer rate by 25% did not impact potato yield. And reducing urea and fertilizer by 25% reduced nitrous oxide emission by 46%. And compared to 106 kilogram nitrogen urea, Super U at 120 reduced nitrous oxide by 6 times. We also observe nitrous oxide emission with forage legumes and higher CO2 and N2 emission with corn, sorghum, Sudan grass rotation, and lower CO2 and N2 emission with soybean, brown mustard. So I don't recall if I mentioned that with the brown mustard, what we do in Prince Edward Island, brown mustard is incorporated at full blooming, and because within 5 weeks we can incorporate the brown mustard, is basically incorporated. We wait for 1 week, and then again we plant brown mustard. It's what we call double cropping. So basically, this is the rotation with lowest carbon input, but also the most disturbed soil with 2 tilling during the summer before potatoes. So now the question I have, most of the growers, they ask me which rotation is best. So keeping in mind that the results I presented on greenhouse gas emissions were only during potato phase. So let's try just to make hypotheses. If we had to analyze the greenhouse gas emission over the whole rotation cycle, what we can expect. And by the way, we are doing this because we decided now to assess the whole rotation. So grain corn, sorghum, Sudan grass, these crops are both fertilized. So we could, excuse me, we could expect to see significant amount of nitrous oxide emissions emitted in year 1 and year 2 in this rotation. So the second rotation, barley red clover. So red clover, we apply for barley 50 nitrogen unit. And then second year is a legume, so no nitrogen applied. So we could expect moderate emission of nitrous oxide emission, but then in the second year, because it's a legume and the land is not disturbed, we could expect less carbon dioxide and nitrous oxide emissions. For soybean, it's a legume, not fertilized, and then brown mustard, we apply basically 50 kilogram unit twice per growing season, and we till the land twice. So basically what I want to say is that we have to consider the whole rotation system in order to decide which one is actually increasing greenhouse gas emissions. And also we have to consider other parameters, not only the greenhouse gas emissions. I just gonna show some result from other study conducted on the same rotation. Kakpazan is based in Brandon, Manitoba, is an agroeconomist. So he did assess the profitability in this rotation between 2015 and 2021. And he observed a slightly higher profitability in the rotation that include sorghum Sudan grass and brown mustard than the standard rotation. And then a recent student at Dalhousie used the same trials to assess carbon and nitrogen stocks, and she observed that the carbon stock were comparable at 0 to 45 centimeter depth across rotations, but the standard rotation that includes a forage legume had higher carbon and nitrogen stock only at 0 to 15 centimeter depth. So what I want to say here is that we need to check multiple parameters before we decide which rotation is best. So good news from this study is we can reduce nitrogen fertilizer input without impacting yield, while significantly reducing nitrous oxide emissions. And we also know that the soil is primarily the source of nitrogen for plant growth. So this is a study I conducted over 10 years, where I was assessing the soil-derived nitrogen contribution to potato crop. So the way we do it, basically over multiple years, during potato phase, we were leaving a part of the plot without nitrogen fertilizer, and we were quantifying the total nitrogen accumulated in the potato plant by sampling tubers, above ground biomass, and roots. And we did have contrasted rotation and a different timing of tillage. Sometimes we were doing the tillage in spring versus fall. Sometimes we were fray mowing red clover before incorporation, or we were spraying it with herbicide. So what we observed that the soil alone could supply between 75 to 136 kilogram nitrogen per hectare. So it's variable, is weather dependent, and is hard to predict. So in Prince Edward Island, we do not have a soil nitrogen test. As today, we cannot tell a grower if you have alfalfa or red clover before potato, this is the amount of nitrogen you could reduce. We don't have that test yet. But there are studies, we are working on this. There are previous studies that are showing that we could predict the seasonal nitrate over the growing season using soil health metrics. These are the study by David Burton and Bernie Zibart. So basically, they found that when you use total nitrogen and a labile pool, that's what we call biological nitrogen available from a 2-week soil incubation. The BNA is a test that has been included in PI analytical lab. So this basically the rapidly mineralizable fraction. And then you use total nitrogen, total soil nitrogen, that basically showing the long-term soil fertility capacity. So they used a pedo transfer function, and they saw that they could predict the soil mineralized over a longer term that was 120 days. So we are building on this study to help to find a soil nitrate test to be able to predict nitrogen that could be mineralized over the growing season. We do have also under Living Lab a study where we are working in a commercial field, and this is a 4-year study from 2024 to 2027. And different growers are testing a different rate. So we do have a grower's standards and fertilizer rate. Then we have 50% reduction and 25% reduction. They are also leaving a check. And most of the preceding crop are red clover and alfalfa. So we are trying to address that issue of being able at least to give a number to growers how they could reduce nitrogen when the preceding crop is a legume. So that is the end of my presentation. I want to thank everyone for your interest in this research topic, and I welcome your questions. Thank you very much.
All right. And with that, questions are officially open. There was one that came up through the presentation, and William asked, as you were going through there, it was you had 2016, 2019, and 2023 as your years, and he was just curious if it, following the pattern, he felt 2022. What was that?
Okay, good question. Yes, that is a 3-year rotation. I know that it was something that happened during the pandemic. So the site would have gone to potatoes, and because we were trying to minimize the crop that was intensively demanding, there was a time where we should have gone to potatoes. We went with barley, but otherwise it's every 3 years we do have cover crop, and then we quantify the biomass. So it's supposed to be a pattern of every 3 years, but I remember something happened during the pandemic.
That makes sense. That pandemic definitely threw off a lot of stuff.
Yeah.
Wonderful. I'm going to ask a question because it looks like what I'm hearing from you is that there is predictability and there are trends that you are seeing in this. Would that then suggest that this is something that could be implemented across the country, and that this is, I guess, basically anyone listening anywhere, if there's potatoes being grown, there is a trend, so these results would be transferable?
Under the same soil type, if you are in the sandy loam soils, same rainfall, potato systems, yes.
Okay, perfect. Then adding a little bit to that, what conversation should a CCA be having if they're looking to implement this system elsewhere? So if they're speaking with their producer, what should they be looking at to introduce something similar?
I think it's also important to see the system you are working with. I would give an example. In New Brunswick, they are our neighbors. They don't follow a 3-year rotation system. They follow a 2-year rotation system. I think because agriculture is important in Prince Edward Island and we intensively cultivate our land, I think also by having a problem of erosion, so we go with a 3-year rotation, try to give a break to our land. But maybe someone in Western Canada who you have more fertile soil, maybe a 2-year rotation may be a good way to go. But definitely having like sorghum Sudan grass or pearl millet, breaking that cycle of rotation for breaking the disease cycle, I would say the short answer is to see your system, what is allowed, what is not allowed, but also what is your objective. Someone may have a very fertile soil, but we know as you crop potato frequently, the soil will degrade down the road. So including a rotation that increase the carbon return is beneficial, and any rotation, because diversifying is also important. Diversity is important of the crop just to reduce disease pressure.
Perfect.
I don't know if I answer your question.
That was exactly what we wanted. Anything that
Okay.
we can do to make it specific to different areas, love it. Perfect. Myrna, I see your hands up.
Yeah, so I was wanting to engage some of the other attendees on this call. I see a few certified crop advisors out there and some professional agrologists, and I was just wondering what you're hearing when you talk to the farmers would be one of the biggest barriers when you're suggesting a diverse rotation in the potato systems.
In our province, this is common. So because it's mandatory, they all do. The only thing sometimes happens is because there is no best rotation, it will always depend on the farm. So if someone does not have any disease, can actually go with a legume as long as we are able to reduce the nitrogen applied. Sometimes it's just the contradiction that some rotation may increase the weed pressure. Sometimes you can have the disease. So they would like to have all answers, all their question answered. So a weed scientist saying you want to have disease pressure, you want to have weed pressure. So they want to make sure that before they adopt any rotation, if they are not going to deal with weeds or disease. But in PI rotation, diversified rotation is something that is being implemented already.
So Dr. Nyaraneza, just to add on to that, was there anything in the data that surprised you or results were different from expectations?
Yes. So the rotation that included brown mustard. So we do have intensive cultivation and we have low residues. So I was not expecting that rotation to have carbon and nitrogen stock comparable to a rotation where you have sorghum and corn. That rotation that actually return more carbon. So I was digging and I see Mervyn here, and there was a paper recently they published that was showing that the brassica crop, they do have the glucosinolate, and when they hydrolyze, they can delay the nitrification, the mineralization. So it was intriguing, those results, because I thought maybe there is something with brown mustard that delays soil mineralization, but that should be temporary. So I could not understand because I was expecting to see that rotation to have carbon nitrogen stock very low, but it's comparable. So all rotation are viable, and that was surprising in my opinion.
All right, are there any
Mervyn.
questions? Are we seeing any questions from anyone else out there? Sorry, Jordan, I don't mean to cut in.
No, cut in, please. No, that was, we've got
Okay.
nothing coming in yet. But I think there was, Myrna, on your first question there, I think that you were, I think we want to hear from people in the audience on what they're
Yes.
seeing. Because this is
Yeah.
a big part. CCAs that are in the audience right now, this is a good way to get your insights to the experts and let them hear what you're seeing. So we will open that up for a few seconds. And if there's some people that do want to unmute and give their 2 cents, we would love to hear that as well.
I know some of you may be listening on your lunch hour or while you're driving or wherever you may be, but I don't know, David, I don't mean to call you out at all, but are there any things that you've been hearing from farmers or producers or anyone else that could be a barrier or that they're frustrated with, or when they talk soil types, climates, different parts of the country?
Well,
Good question.
Oh, David, go ahead.
Someone has a question first.
yeah.
well, I think the big thing right now, Myrna, is a lot of people are, it depends on how you adapt these products that fit the logistics of your operation, price considerations, and does the ROI work for your farm? I mean, reducing greenhouse gas emissions is important, but at the end of the day, it's the ability to pay the bills is what drives adaptation of these products. And I know even talking to producers with adopting some of the programs that are out there through Fertilizer Canada to help reduce emissions, it comes down to, is the cost worth the additional effort? And that comes down to a producer by producer basis. So.
Okay. Oh, we do have a couple questions in the Q&A, and William had asked, what was the, or did we ask this already? What was the potato
that was the one I
variety
got.
you used?
Nope.
We got that one, yeah. Okay,
Nope, no,
have you, go ahead.
I was gonna say, I didn't see the variety one.
What was the potato variety that you used, Dr. Naranenza?
Yes, we did use a mountain gem.
Okay, because it says here, because they require different optimum rate of nitrogen, whether it's a russet Burbank or a russet Norcota. I don't know how to say that.
Yes, that's a very good question. So in PEI, just to give you a context, growers could apply up to 200 nitrogen per hectare. And for early variety, they can go 120 to 140. Mid variety 140 to 160, and then late variety easily 180 to 100. So this variety was basically a mid to late variety.
Okay, William, did you have anything to add to that one to follow up? If not, that's fine.
I can
You
just comment on
Sure.
David's comment. I think he's perfect, right? You know, at the end of the day, the grower needs to pay the bill, and that's why we don't focus only on one thing. We try to see soil health metric, we try to see nutrient cycling, we bring in an agroeconomist, just because we know it's important for them also to assess the profitability.
And one
did
more.
did Florencia's question get asked? Have you observed a reduction in disease incidence when using mustard in the rotation?
Very good question. We do have a colleague who is assessing, we keep potato tubers at harvest, and he does go through the scab and other disease, but I don't have his results here. He's a phytopathologist, but yes, we do work with phytopathologists because we know that is important.
So if someone wanted to get in touch with you or some of your other colleagues, what's the best way for them to do that? Do you have a contact information?
Email, I can
email?
put it in the chat here. Yes.
That would be great. Yeah, no,
Yeah.
that's excellent. I'll turn it over to you, Jordan, just sort of wrap up.
Well, and that is a perfect place to wrap it up on is, again, a big part of these engagements and the Interconnect sessions is the back and forth between industry and the researchers. So definitely we encourage that point to reach out. And again, just as we do close off here, thank you to Dr. Judith for a presentation. And again, Thursday next week, noon Central, we do have our next presentation. And they are being put up for CEU points. So again, that will be coming in the next few weeks. We will be sending out in an email a follow-up on how to take quizzes and get your CEU points. So on that note, thank you to all for tuning in, and we will see you all next week, same time.
Thank you, everyone who joined.
Thank you.